Okay, hello everyone. My name is Faye, and in this particular video, we're gonna do exercise with recursion. Okay, so let's jump to the first question about odd number series. If you working with recursion, I always advise to you looking at the input and output table first thing you do in solving the problem. So here we have a input 5 and output 135. Input 20, the output will be 13579. Okay, so by seeing this, we know that we want to output a number in range of 5 or number in range of 20 according to user's input, but only the odd numbers. Okay, so how do we do this in recursive time? So this is how you do it. Okay, let's focus on the odd number. As you can see, I have base case, okay? And what I want to do in the base case, I have inputs 5, and in my base case, I will output 1. Okay, so if it reaches my base case, which is 1, it will output 1. So what I do next, our recursion case, what we do? Okay. As you can see, I call the odd number procedure. Okay. Notice I say it procedure because it doesn't return anything. Okay. Recursion is recursion is function or procedure that call itself. Call, okay, it's not return. So a recursive is not always returning something. Okay. So I call it's odd number call itself and minus it by 1 so it can reach the base case. This is what it does. And the condition on the bottom side of odd number will be if the number right now is a odd number, we print it. That's the condition. Okay. Notice on why I call it first, and after that I do the printing because we want to do it ascending. Okay. If we want to do the descending one, we move this to the bottom. Okay. But if we want to do ascending, we move it to here. So let's run this. Let's go to recursive exercises. Okay, so go run odd number series. So in my main, simple just call the function. I call the procedure. Okay. So if I have 5, 135, if I have 20, 190. I always advise you guys to do tracing by yourself because that's really what recursive and recursion do. Just a lot of tracing, okay? A lot of tracing. So in our course, I already teach you guys on how you trace trace your recursion. So try to do this as your exercise by trace this code in your own paper on where you want to do it. Just do it because that's the core of recursion. Okay, so let's go to the second problem. Factors of a number. So by seeing the title of the question and seeing the table, if you have input 5, the output will be 1 and 5. If you have input 12, 1, 2, 3, 4, 6, 12. Every number, a series of number that can divide your inputs. Okay, many thing to, there's, I think, 2 or 3 way to approach this question, but this is what I choose to approach my question. So notice on why I have two parameters on my procedure. Why do I have two parameters? Because I need to have time variables to store my original value of n. So you will understand this after seeing the code because you will have time modulus n, which is every function called will be -1. If I doesn't have this time variables or this time parameters, I cannot store the original number and I cannot do this line 18 thing. Okay, so what this recursion have, it has a base case 1. If it reach 1, it always printing 1, and else same as before, I call it first factor, and after that I do the printing. I do the printing if the current number can divide the original number. Okay, so time is an original number. There's another, how you say this? There is another approach for this. When you just declare something outside every function, including your function main, outside it, you declare like this, var original integer. It will be a global variables that will store in your main. You can do original is n, and what you do, you can use original in your factor recursion like that. Okay, so this is the procedure or a function inside its own self by variables will be n here, and our constant variable will be temp, like that. Okay, so that's for the second question. We go jump to the third question here about x power y. So what this question wants to do is, if you have input 2, it will say it will processing 2 power 2, which is 4, 5 power 3, which is 125. Okay, so how do we do this? Same as before, power function will have a base case. What you want to do in this code is actually, if you have x power y, what you want to do is you want to do x times x times x times x over and over again until y times. Okay, so the changing variables every function called to reach y is 1. And where y becomes 1, it will return x, okay? Because it will always do multiplication x times x every function called. So as you can see, we need to reach base case. So every function called, we use y min 1. And the constant variable, which is x, we always times it with itself, which is x, and function main just call the function and print in the function. Okay, don't forget, if your recursion doesn't return anything, you need to print it in your main. Okay, so that's xpow for you. And we go for the fourth problem. I think you guys are already familiar with Fibonacci, and maybe at this time you already bored with this Fibonacci, but we try to do it with recursion approach. So Fibonacci will always have a two case. If the Fibonacci start from 0 and 1, you have a condition when it's 0 and condition when it's 1. And what you do outside itself would be call the function, the two previous plus the previous one, like that. So that's what you do in your Fibonacci. I think I want to explain you this by looking at this code and see the return value at the bottom. As I say before, the recursion will always need a function, just a general function or procedure. When it function, sorry, it always returns something. So it needs something to return in all conditions. So if you have example 2, it will return this, 3 will return this, 4, 5, 6 will return this. Okay, you can also do this, else, and you go to bottom like this. Still works like that. Okay, if you understand it more like that, do it. How do you like it? You do it. So that's about Fibonacci. And after that, we go to patterns. Okay, using asterisk. Pattern is a unique one because you have an alternative. But what we do right now, we see the main approach I want to go. As usual, I have a best case. When it's reached 1, it will printing asterisk. And maybe you will a little bit shocked in this else condition because it has a loops inside it. So if you using patterns in your for loops, you always use double loops, okay? Loops inside loops. That's why you, because you always want to approach this question by printing it with its column, okay, and its row. So you need two loops, okay? So in your recursion, your recursion will act as a column, and your your recursion will act as a row, and your patterns will act as a column. So and your for loops will be your column. That's how you do this patterns question. As usual, main just calling the patterns. As you can see, it doesn't return anything. It's a procedure. And what I say like before, we do the patterns before we print it, because we call the function before we print it because we want to do it from top to bottom. If you change this, if you do patterns from the bottom, it will do how do you say this? If you have this 1, 2, 3, 4, 5, it will be otherwise. It will be 5, 4, 3, 2, 1. Close the door. So that's how you do the program. But I have alternative if you want to do. So in your alternative approach, you will make two function that will be called inside another function. So if you have a pattern, it will do the recursion by calling itself, but it will call another function, another recursive function in other line. So if you can see here, in line 33, I calling print stars. In print stars, it's a my own recursion function, and my recursion procedure. So that's how I do my alternative. Choose what you like, but this is my approach, the easiest way to understand. But this one is better for the recursion context. That's why I give you another alternative. So for our exercise in this video, that's all. And for source code, you can access in description box below. That's all from me. See you in next video.